Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples. Good afternoon, and welcome back to Stories from Space. I'm your host, Matt Williams, and today I want to kick off a new segment that explores the possibilities and the potential for human habitation throughout the solar system. And this includes all known planets and celestial bodies. What are the challenges? What are the solutions? Is it feasible, and when can we expect it? And naturally, I want to start this segment off by looking at the moon. Lunar colonization, or for our purposes, I like to use the word settlement. Lunar settlement is the next logical progression of human expansion into space beyond low Earth orbit. In order to settle in new Earth orbit, we need do nothing more than build space stations, ones that are regularly accessible, that can be crewed by rotating personnel year-round, and that service everything from space tourism and hotels and research and manufacturing to providing support for exploration missions beyond low Earth orbit and possibly beyond the Earth-Moon system to locations in deep space. And what's more, the technology already exists to establish a human presence in low Earth orbit. We've already done it. Multiple times, in fact, through the Salyut space program, which was conducted by the Soviet Union between 1971 and 1986, and the Mir space station, and also NASA's Skylab and the International Space Station. And there's plenty more to do there, but the point is, we've already established, we've validated the technologies and already conducted the necessary experiments to know that human beings can live in low Earth orbit for extended periods of time. And some of the future efforts would include centrifuges and rotating pinwheel stations that simulate gravity so that the effects of microgravity can be mitigated and addressed in a way that is long-term, long-duration. As for the moon, not only is it significantly farther and therefore more difficult, time-consuming, and expensive to reach, but living on the lunar surface means dealing with a slew of conditions. These include, but aren't limited to, the fact that the moon is an airless body. It's beyond Earth's magnetic sphere, which means that it's not only subject to a lot of micrometeoroid and asteroid impacts, but also an intense amount of solar and cosmic radiation. And, of course, the vacuum of space. All of this places a rather hefty burden on anyone who intends to settle on the moon, on workers, on crews that are sent there to build and maintain the structures and facilities, on the people trying to make a new life there. To do that indefinitely really requires that we both lean on our technology pretty hard and come up with long-term solutions that just aren't available yet. However, it is within the realm of possibility. It's just a matter of determining how much are we willing to spend, how much time, effort, and energy are we willing to commit to this in a multi-generational sense, and what are the benefits? Are they worth the effort? So to break it down, what we know about the lunar environment is based on the roughly 6 decades of exploration involving robotic rovers, orbiters, landers, and of course crewed missions, the Apollo missions being the only crewed missions to date. What we've learned thanks to all the robotic missions and the Apollo mission and the moon rocks it brought back, and also sample return missions conducted by the Soviet space program, indicated that the moon and Earth are very similar in terms of composition and even structure. Which is to say that, like Earth, the moon is composed largely of silicate minerals and metals that are differentiated between a crust and mantle, which are largely composed of silicate minerals and trace amounts of metals, and a core composed of iron-nickel. The first lunar samples were also found to contain traces of water, And at the time, scientists believed this was the result of contamination, that it was not possible that water existed on the moon. But scientists have since confirmed that not only is there water, which is the result of solar radiation interacting with oxygen on the surface, but that around the polar regions of the moon, there are abundant caches of water ice, which are all located in these permanently shadowed craters. And it is theorized that this ice was deposited there by the very same comets and asteroids that caused the impact craters in the first place. And that this happened billions of years ago during the late heavy bombardment period, a very chaotic time in the solar system when there was lots of objects flying around from the outer solar system to the inner solar system, and that it was this period where water was distributed throughout the system, and that includes to Earth and the Earth-Moon system. It's even speculated that this same period distributed the building blocks of life. In any case, the similarities in composition structure are what led to the predominantly held theory of how the moon formed, which is known as the giant impact hypothesis. The basic idea here was that shortly after Earth formed, roughly 4.5 billion years ago, a Mars-sized object that was kicked out of the outer solar system, which scientists have named Theia, that this object collided with Earth, causing a tremendous amount of molten material to be kicked up and into space, and over time, this material, it cooled and resolidified to form both Earth and the Moon as separate bodies, and that the Moon slowly migrated out to its current orbit. And research conducted during the Renaissance era by Galileo, Kepler, and Newton revealed that the Moon is responsible for the tides here on Earth. In more recent years, it's also been suggested that the tidal interactions between the Earth and the Moon is also part of what drives Earth's magnetic field. The reason for this is because Earth's magnetic field is generated, so the theory goes, by Earth's core region, which consists of a solid inner core and a molten outer core. The molten outer core revolves in the direction opposite of the Earth's rotation. And this happens to coincide with the Moon's orbit, so it is believed that there is a connection there and that the Moon's gravity is what helps keep our outer core rotating. This not only ensures the long-term survival of plants and animals on the surface, but it's kept our atmosphere from being stripped away by solar wind, which is believed to be what happened to Mars. So, based on these similarities and the fact that the Moon has confirmed deposits of water ice in its polar regions, especially around the South Pole Aitken Basin, there have been multiple proposals for how human beings could establish a foothold on the Moon and even a permanent settlement there, and of course multiple space agencies today are not only contemplating that, but are deep into the planning stages of that. The most notable of which is NASA's Artemis program. So to address the question, what's it going to take? What can be done? Well, to recap, the challenges are an airless body approaching vacuum, temperature extremes, high amounts of radiation, micrometeoroid and or asteroid impacts, and on top of that, as the Apollo astronauts can attest, lunar regolith, or moon dust, is also very hazardous. It consists of tiny little shards of silica, so rock that has been pounded over and over and over again by asteroid impacts over the course of billions of years, and because of a lack of an atmosphere, and therefore no precipitation, there was no wind or water erosion to soften it up, so it still exists as sharp little shards that are also electrostatically charged, thanks to interactions with solar wind. And what that means is it sticks to everything. So the NASA astronauts, they found, as they ventured out onto the surface and then got back into their lunar modules, they found that not only was it extremely difficult to get the lunar dust off of their suits, but that it would stick to all the surfaces inside the lunar lander, and it caused all manner of problems with mechanics and electrical systems. If it got into the panels, it would wreak havoc. So, with all that in mind, the name of the game for creating a moon base or a permanent settlement is, first of all, location, location, location. So basically, the best place to build, according to all of the plans, all the best information we have on the moon right now, is either around the poles, where there's abundant water ice, but also where temperature variations are significantly less. Around the equator of the moon, temperatures will range between periods of direct sunlight and extended periods of night, from about minus 173 degrees Celsius, or minus 280 degrees Fahrenheit, to a high of 117 degrees Celsius, or 242 degrees Fahrenheit. So basically, temperatures around the equator will range from extremely hot to cryogenically cold. Now, of course, this is just on the surface. The slightest bit away from the surface, because the moon is an airless body, and immediately the temperature drops off considerably to near vacuum temperatures. However, that kind of exposure to direct sunlight and that kind of extreme cold is still very, very hazardous for astronauts and crews and anyone attempting to live in that region. Around the poles, on the other hand, it is always very cold, but the temperature range is significantly less. It goes from minus 123 degrees Celsius, or minus 190 degrees Fahrenheit, to minus 43 degrees Celsius, or minus 46 degrees Fahrenheit. Which, as I said, still very cold, but is workable with the right kind of technology and solutions. Another option is to build within stable lava tubes, which have been found on the moon in multiple locations. And these are a bit of a throwback to when the moon was still volcanically active, so when it was still very young. Basically, volcanic activity happened on the surface, which is still evident today, and from these volcanic spots, lava tubes were created that extended outwards. Many of them collapsed, which have made them discernible from the surface or from space. They're known as sinuous rills. They basically look like little depressions in the ground that extend outwards in long, crooked lines. But in many places, the tubes are still intact. They haven't collapsed yet, but they are accessible because of these little holes in the surface known as skylights. So theoretically, settlements could be built inside these. They'd be protected not only from harmful radiation, but also from the elements of space. Speaking of which, the next important thing, without which no lunar settlements can happen, is the need for protection against the elements. So this can be done in a number of ways, one of which is to create a structure with a very strong outer shell, or to build bases that are largely underground, like the aforementioned case of building in stable lava tubes. They still need to have access to the surface, and they still need to permit natural light to get in, but otherwise, the majority of the facility can be built downwards to maximize protection by using the regolith itself as a barrier for natural radiation shielding and also protection against micrometeroids and larger impacts. Another possibility that has been explored is to use artificially generated magnetic fields as shielding. Now, these will protect against harmful radiation, allowing for habitats that are largely on surface, but not impacts. So additional shielding in that case would be required. Protection against the elements in lava tubes also requires that you seal off the section where your settlement is being established. So basically, establish walls on either side of it, possibly through material that is transparent that will allow light from skylights to be visible, and of course is equipped with airlocks that you can then pass through to go to the skylights and gain access to the surface. But you have to contain a section of that lava tube in order to generate an atmosphere in there and maintain it. Alternately, you can also establish a settlement that is entirely interconnected, inflatable structures or rigid structures. As long as they all have self-contained atmospheres and are connected to each other, then you're once again shielded from the near vacuum of space. A third major consideration is how to source all the building materials and pretty much everything you need to maintain and operate a base on the lunar surface, how to source them locally, and this is known as in situ resource utilization, or ISRU. What's involved here is leveraging the local resources to lessen dependence upon Earth, because it is very expensive to send payloads to the moon, And given that it takes several days to get a ship there, regular operations within settlements, they have to be a lot more self-sufficient than what we currently see with the ISS and any orbital space stations. Those can be resupplied in a matter of hours. But on the moon, astronauts and eventually civilians are going to need to see to their own needs as much as possible. Now, for NASA and the European Space Agency, who have been conducting research into possible building methods and building materials for the moon, and this has been ongoing for about a decade now, the solution is to send robots equipped with 3D printers that could harvest lunar regolith and use it to create either a form of lunar concrete or molten ceramics, which could then be used to build the superstructures, the outer shells, of any bases or habitats on the moon. Now, in the European Space Agency's case, years ago, they began working with an idea for what they called the International Moon Village, which would be a successor to the International Space Station, and the plan called for mixing regolith with a bonding agent to create lunar concrete, or lunacrete, and they actually tested this method using a lunar regolith simulant and found that they could print a strong, durable cement that would definitely make a good, solid superstructure to any base facility. Since then, the European Space Agency has come up with another proposal, which is for the Moon Village. They dropped the international from it, and this consisted of sending lightweight, semi-inflatable structures. So they consist of hard paneled outer edges and an interior inflatable module. These would then be landed on the rim of a crater and pressurized so they would expand. They would then be connected to form a larger facility, and solar arrays would be set up around them on the rim of the crater in order to capture sunlight and provide power. And water ice would then be harvested from the crater floor to provide for all of their needs. In NASA's case, it involved equipping robots with sintering technology, which is the process of bombarding metals or silicate minerals with microwaves. So their robots would have these microwave modules connected to their arms, and they would take in regolith and then funnel it to these units where they would be bombarded with microwaves, which would turn it into a molten ceramic, which they would then proceed to print out onto the surface, which would cool on contact with the near vacuum of space and solidify to form a solid structure. So here too, lunar dust would be the basis for the main building materials for creating ceramics and concrete, and these would be printed over top of inflatable structures. NASA's most recent proposals for the Artemis program, they include the Artemis Base Camp, a deployable structure that would be out on the surface. However, they're still entertaining long-term plans of creating a longer duration facility there, a more permanent base that would leverage technology like sintering and 3D printing. And in any case, wherever these structures are deployed or built, there's still the option of building underground, of having a sort of a recess below the surface habitat where astronauts can go in the event of a major solar flare or there's asteroid impacts taking place. And there's even been proposals to use the Starship as a temporary base, that once they land on the lunar surface, they can be lowered down on their side, covered up with regolith, allowing for airlocks to still provide access to the surface, but otherwise the interior space can be then cleared out, all the fuel tanks can be removed. It will provide a good-sized living volume and radiation protection, and from there, crews can then venture out onto the lunar surface and build a more permanent facility. So these ideas address radiation protection and exposure to the elements. They also address building materials, and they certainly take into account resource allocation there, such as water. In terms of power, as I mentioned, solar panels are a definite possibility. Any facilities on the moon would definitely need to have several solar arrays set up in order to draw power from the sun, especially around the South Pole Aitken Basin, where, since its polar region, receives quite a bit of sunlight for extended periods of time. However, other methods are needed too, because on the moon, the diurnal cycle, or the cycle of day and night, is much longer. A single day lasts about 2 weeks, and same for a night. So for 14 days at a stretch, bases are not going to have the option of drawing solar power. And that means that other options such as fuel cells, batteries, or nuclear reactors need to be included as well. And NASA has, of course, been researching this as well, and their efforts have led to concepts like the kilopower reactor, which has since evolved into the kilopower reactor using Stirling technology, or CRUSTY. As for food, now thanks to ongoing research aboard the ISS, we know for a fact that astronauts can grow their own food in space, and that plant greens especially, they can be sped up in a centrifuge, simulating gravity, which will allow for good crop yields, which can certainly supplement an astronaut's diet. Now, long term, it is difficult to say what astronauts are going to do if they need to be largely self-sufficient in terms of agriculture and food production. A vegan-based diet is certainly very healthy and is likely to provide astronauts with all of the protein and nutrients they need, but the sheer volume of food that they would need to create in order to minimize dependence on Earth, minimize resupply missions, looking at the long term, it's a significant challenge. In the short term, it really wouldn't be much of a problem. They can certainly maintain supply chains with Earth for the majority of their food, but long term, the best bet right now, which is being explored, is probably to have lab-grown, lab-cultured meat. That way the astronauts can grow their food from cells in a lab, and this can provide a steady source of red meat or white meat with all 8 essential amino acids, rich source of protein, iron, and all the other nutrients that one typically finds in organic farm-raised meat. And, of course, the necessary fats, too. Alas, the one challenge for which there's no solution right now is the issue of gravity. Now, lunar gravity is roughly 16% that of Earth's, and we do not know, there's been no research to date on what the long-term effects of that are going to be on the human body, but it is safe to assume that it's going to be very similar to microgravity. And the effects of that on human physiology have been studied at length aboard the ISS. And from that, we know that after a period of acclimation, spending a few months or up to a year, which has been done several times by a handful of astronauts, not the least of which is Scott Kelly, who spent a year aboard the ISS as part of the NASA Twin study. We know from all that the effects include muscle atrophy, bone density loss. There's also disruption to the cardiovascular system. There's changes in organ function, eyesight, gene expression, and even the central nervous system. And all of this, we know that with the right kind of regular exercise and proper nutrition, that the human body is very resilient under these conditions. It can adapt to a point, but human beings cannot live in space indefinitely, not unless they've got access to some sort of simulated gravity. Regular exercise and resistance training, unfortunately, is just not enough. Now, the answer to that may come in the form of centrifuges, or more likely, rotating habitats in space. And that's something that NASA has already been contemplating and investigating through their Nautilus X program. And the idea there was for a rotating torus that could be included in the design of a spacecraft for deep space missions, such as missions to Mars, or included as a module on the space station where astronauts would sleep. And that torus was really only large enough and would be spun up enough that it could simulate roughly a third of Earth gravity. So to simulate a full 1G, you need a sizable space station in orbit that astronauts could travel to, or rather civilians and settlers and crews that are living and working on the moon for long stretches of time. They could travel to this torus-shaped space station and periodically spend a few days just undergoing gravity therapy. Now, these address the fundamental challenges of establishing a human presence on the moon, but they don't address all of them. In fact, there's a number of potential factors and hazards that we really cannot investigate at this time because there's no frame of reference, there's no real chance to conduct that research. And that includes the psychological effects of being away from home. And I mean that not just in the sense of human beings traveling from Earth to the moon for long-duration stays, but rather just human sense memory. We are creatures that evolved in the terrestrial environment of Earth with an atmosphere, a magnetic sphere surrounded by nature. That's in our bones, it's in our DNA. If you put that kind of organism onto a new celestial body where the gravity is significantly less, where you can't wander around outside, and where you're living largely underneath a big thick dome or underground, there's no real telling how that's going to affect an individual over time. And even with the option of gravity therapy, it's still not clear whether or not human beings, or animals for that matter, can procreate in this environment. How is that low gravity going to affect fetal development? Does it mean that anytime a woman gets pregnant, or an animal is impregnated, that they are going to have to be relocated to the station to spend the duration of their maternity? We're not just talking about fetal development, but early childhood development too. And how long does that take? We may inevitably discover that only adults can travel to the moon. Only people can go there once their bodies are finished growing and their brains finish developing, and that, therefore, there is no adolescent population on the moon. There's no possibility of raising families there. Like I said, that is a big unknown. All we really know for certain is that the main challenges, the ones that we can foresee for the near future, they can be addressed. It's just that, for the most part, it's a question of how much are we willing to spend, how committed are we to doing it, and what are the advantages? Will they make it worth it? So, having said all that, what are the advantages of establishing a settlement on the moon? Already there's been a number of studies and proposal papers, and space agencies have certainly been rather vocal about what the advantages could be. There's no shortage of ink spilled on the subject. And for the most part, they emphasize resources. The moon has abundant metals, being similar in composition to Earth. It could be a source of abundant rare earth elements, which are very important to our current and growing economy, in which electronics are central to everything, and rare earth elements are essential to creating those. There's also the prospect of helium-3 mining. Now, estimates vary as to how much helium-3 is actually on the moon and how much of it is accessible, but what we do know is that it's more abundant on the moon than on Earth, due to interactions between solar radiation and the lunar surface. And so that could be harvested for fusion reactors. It is safe to assume that by the time a lunar settlement would be created, that advances in fusion technology and tokamak reactors and miniature fusion reactors, that this will be a viable power source for Earth and for the moon, and therefore having a supply of helium-3 would be very advantageous. And of course there's the advantage of having an outpost on Earth's nearest celestial neighbor as a means of facilitating human migrations beyond Earth and beyond the Earth-Moon system, to places like Mars and Venus and the asteroid belt. In fact, establishing a foothold on the moon with all the necessary infrastructure on the surface and in orbit, and that would include refueling facilities, this would shave billions off of missions to deep space, and would also facilitate further expansion of humanity out into space and the harvesting of near-Earth resources, asteroid mining, etc. Basically, the creation of a post-scarcity economy, which is a major selling point for a migration to space and humanity becoming an interplanetary species. Yeah, the creation of that era of post-scarcity economics, it starts with establishing a foothold in orbit, but then on the moon. And whereas the commercialization and a permanent human presence in orbit is anticipated for the coming decades, a permanent habitat on the moon could conceivably follow by mid-century. There's a lot that would need to happen in the meantime, but it is within the realm of possibility, as I said. And what's more, a lot of that is happening right now. And that includes NASA's Artemis program, which successfully launched the first Artemis mission, a circumlunar flight using an uncrewed Orion space capsule. which went farther than any spaceship has ever ventured. So this was a major accomplishment. And the Artemis II mission is currently scheduled for November 2024, and that will consist of a crewed mission making the same circumlunar flight. And if all goes as planned, this will pave the way for Artemis III, which will see astronauts land on the surface of the moon for the first time since the Apollo era. Not to be outdone, in 2021, China and Roscosmos announced that they are entering into a partnership to develop the International Lunar Research Station, or the ILRS, which is intended to be a direct competitor to the Artemis program, and based on the architecture that they've shared so far, it is highly reminiscent of the Artemis base camp, calls for multiple facilities on the surface, including a central habitat, a mobile operations facility that can move around the surface there as needed, a scientific research facility, a ground support facility to conduct launches and receive incoming spacecraft, and a transportation facility for their vehicles to be stowed and to charge. However, this was before the current crisis in Ukraine, and it is unclear at this time whether or not China and Russia plan to go forward with this program together. But it is very likely that China will go it alone if need be, because the plan called for China to be doing most of the heavy lifting anyway, so there's really no reason to assume they can't carry on without Roscosmos. And it's also worth mentioning the Artemis Accords, which NASA drew up in 2020, because it was in direct response to these accords that China and Russia came together to announce the ILRS as a competing program. In any case, several key members of the European Space Agency and the Canadian Space Agency and the Japan Aerospace Exploration Agency, or JAXA, and many other international partners have signed on to the Artemis Accords. So the Artemis program is going to extend well beyond just NASA, and the ESA's proposals for an international moon base, which would be the spiritual successor to the International Space Station, they are likely to happen. And it is safe to assume that within a decade, ground will be broken on that project, and we could have a permanent international facility on the moon at the same time that crewed missions are headed to Mars, which is scheduled to commence by 2033. And given the current rate of growth and a somewhat optimistic projections, assuming that the budget environment remains steady, and that the associated costs of sending crews and payloads to space continues to drop, it's not at all unrealistic to think that a permanent base and lunar tourism will be established by mid-century and possibly even the beginnings of a permanent settlement, with a crew of lunar settlers, actual civilians living on the moon indefinitely. One thing's for sure, though, if and when these facilities are up and running, there's going to be multiple flags up on the walls. In short, sending people to the moon is not going to be something that a single space agency does anymore. It's not going to be just NASA and the United States up there. It will be dozens of nations, and given time, even hundreds. The UN is likely to have a permanent presence up there by that time, too. But as I said, a lot needs to happen between now and then. And there are still many unknowns that we just can't account for, and therefore any predictions we make are subject to a fair degree of uncertainty. So, thank you for joining me for this first installment in Humanity Settling the Solar System. Join me next time where we will discuss how humanity can establish a presence on Mars and essentially give new meaning to Mars's nickname, which is Earth's twin, and create the first Martians. Thank you for listening. I'm Matt Williams. This has been Stories from Space.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.